You'll be up first.
Someone's in the chat.
Good morning, all. Is there feedback?
Well, someone said that they couldn't hear you, but then they said never mind.
Oh, okay. So hopefully everyone can hear me now. Welcome to the New Jersey Geospatial Forum meeting, Thursday, March 7th, 2024. My name is Matthew Duffy. I'm the Executive Committee Chairman of the Geospatial Forum. I'm also the County Constituency Chair. If you needed anything in your county GIS world, I would be the one that you would come to. Today we have a presentation from Eliza Gross that we're going to get to, USGS, but first we're going to do some business. We have our constituency groups. Just to go over, we have 9 constituency groups, including the county that I already mentioned. There's the federal, there's land surveyor, there's the municipal government, non-government organization, private sector, regional authority, MPO, state government, university, college, K-12. We have some movement for the members have changed a little bit. As you can tell, I'm new here. Thank you. Sorry about that. As I've already mentioned, I'm the new executive chair, and I replaced Trish Long, who's here. Thank you for coming today, Trish. I appreciate everybody being here. I'd like to see more people in person. Seems like we have a better time in person, but we'll get there, I hope. I also want to say thank you to Gary Venistra for the land surveyor chair, and he's been replaced by Ambrose Jaminer. Is Ambrose here today? Am I saying your name correctly? I thought this G was silent, but I'm not sure if it is. Ambrose is probably online. We'll probably hear from him in a minute. And we also have Ken Fong taking over for Tanya Nolte. We're going to get started with the GIO, Brian Embley, and the state update.
Morning, everyone. Can you guys see me? I can't see myself. Let me just adjust here. Good enough? Yeah. So, morning, everyone. My name is Brian Embley, GIO State of New Jersey. I have just 2 short updates for you today. So first, Esri contract update. No, we don't have a contract yet. But we have some forward movement, which I think is a good step. So the contract with Esri's edits came back from the State Division of Law. They finished their review. That can take a long time. They were quicker than they could have been. And that's back at Division of Procurement and Purchasing at the state. And we have a meeting scheduled early next week between the DPP folks, the Division of Law attorneys, and the Esri team, and hopefully the Esri attorneys. So that meeting is going to be pretty important. Hopefully things will continue there and we'll get that contract available soon. You can ask me when, but I don't know when. It's whenever they come to an agreement. So that's where that's at. We're all frustrated with the time it's taking, but it is moving forward. So that's the light there in that tunnel. The other thing I wanted to share was this spring we have the 36th annual GIS mapping contest hosted by DEP, right? 36 years. Last year was 35-year milestone. So now we're at 36 years. So some info about that. It's a great event. It's going to be on May 1st at 10 a.m. It's at DEP's building on East State Street. So it's an in-person event in that there's 9 categories that you can submit either a paper map or a web mapping application in your category. And any contestants do need to show up in person, right? So that they can present. If you've never been to this, what happens is every contestant has a little bit of time to kind of present their map and talk about it. So we need you there on site to be able to do that. And then if you're a spectator, you just want to see the event, you can, of course, show up in person or you can also dial in via Teams if you're just a spectator. So, so big event. If there'll be more details online at DEP's website, right? That's Patty. You have a question? You have a thought, Angela?
And there's PDFs, but there's also at contest day that has to be made up. Right, but I mean, we can still, so I'll talk to you about it for now, but also we'll definitely be able to look at your
Okay, so for those of you online who probably couldn't hear that, right? You do need, for a contestant, you do need to print something out on paper because they put it on the walls, right? So there's some discussion about that. But if you have a live web app, maybe you print out a screenshot, and then there are some laptops available at the event where people can actually check out your application or your dashboard or what have you. But if you run into any troubles, please, through the DEP website, reach out to that team at DEP and they can help answer. Was there another question?
Do you have entries?
Yeah, DEP has all the previous year contestant or the winners in all the categories up on their website. So you can check it out. And I don't know how many years they have, but certainly last year and maybe a little beyond. So you can get some ideas. The competition can be fierce, but it's a fun event because it's just a, you know, GIS community, bunch of mapping nerds like all of us. You know, I make a point to go just to see what's going on. So that's the mapping contest over at DEP coming up soon. That's it. That's all that I have. Thanks, everybody.
To follow up with your thought, though, if there were projectors, dashboards projected onto the wall in line with the paper, that'd be kind of cool. Just a thought. I called out everyone else earlier, but I forgot one of our members. Trish, I was replacing me with you, but actually I didn't replace you. Stephen Caller replaced the federal government exec committee of chair. Is Stephen here today? Good. So he can't yell at me for forgetting. Sorry about that, Stephen. Okay, so next up, I want to go over if there's any updates for constituency groups. I'd like to start with Steve. You okay to start? Terrific.
Constituency or two. Okay. Good morning, everyone. Just wanted to give a brief update for the Geodetic Task Force regarding the new coordinate system. If you're not aware, NGS did a webinar in earlier February to give an update on the progress and the release timeline. We're going to put a link in the chat to that webinar, and then there's also an accompanying PDF, extensive Q&A that they released after the webinar. So I just want to give a brief summary of what was discussed, and I wrote some things down just to make sure I explain this correctly. All right, so NGS is on track to roll out components of the modernized National Spatial Reference System, or NSRS, starting later this year, with the final components expected to be released by late 2025. Note, this will be the beta version for testing purposes only, and all components will go through testing and feedback for at least 6 months. After all beta components are released, once enough testing has been done and all components, NRS components, appear stable and correct, the Federal Geodetic Controls Subcommittee, or FGCS, will then vote to approve the modernized NSRS. This vote is likely to occur sometime in 2026. Then after the vote, still expect a few months of work to remain before the adoption of the modernized NSRS, which will then become the official coordinate system of the US and be required to be used by all federal agencies. So as you can see, there's still, even if everything progresses on the timeline that they have, we're still probably 1 to 2 years away at the federal level. And then after that, then there would be the adoption at the state and local level. And that's all I have. Again, definitely check out the webinar. There's a lot of information in there. And there's a Q&A. And if you're in this room and not online, have the links, just come see me afterwards and I can get that to you. Thanks.
You're bringing in the chat.
Thank you, Steve.
It's Surveyors Week is March 17th.
Surveyors Week is March 17th.
So I don't know if there's any events going on here. It's National Surveyors Week.
National Surveyors Week. Any events going on? It's also St. Patrick's Day, so it's kind of interesting. Okay. So that was an update from the task force, Geodetic Chair Steve Eckhart. Do we have any constituency group chairs here that have any updates? Does anyone else have an update that you'd like to mention? Does anyone have any geospatial issue that you'd like to go over or otherwise review? All right, well, if that's the case, then we're going to get started with the presentation, if that's okay. Okay. So today we have from the USGS 3D National Topography Model, we have Eliza Gross from the National Map Liaison for DC, Delaware, Maryland, New Jersey, New York, Pennsylvania, from USGS National Geospatial Program. I'm going to adjust you a little bit or try to. Can you tell me if she's in the view here? Can you see?
Yeah.
Oh, terrific.
Thanks. I have a presentation. Do I pull it up here or? Great.
Wait, actually, hold on. Sorry.
We're seeing her the
Yep.
next slide. Notes.
Yeah. This is not- What's going on here? Sorry, one second. Slideshow. To share. You're good.
Is that good?
Yes.
Cool. So, hello everyone. My name is Eliza Gross. I'm the National Map Liaison for New Jersey and Delaware, New York, and Pennsylvania. And I'm going to talk a lot about our 3D National Topography model that we have at the USGS and that we're working on. I'm going to start off with a little bit of history though. So the USGS was established in 1879 and basically given the responsibility of classifying the public lands and examining geological structure, mineral resources, and products of the national domain. And then in 1884, John Wesley Powell, who was the second director of the USGS, he convinced Congress to authorize the USGS to begin systematic topographic mapping of the US. And that was, mainly out west. For example, the Powell survey. The Powell survey, they did trips down the Colorado River to do mapping. And then during the next 125 years, the mapping techniques really evolved at the USGS. They started off as field surveys, developed into photogrammetry, and now to the computer-based methods that we use. So the USGS was established under the Department of the Interior with other agencies like the National Park Service, Bureau of Indian Affairs, Bureau of Land Management. And nowadays, we do a lot more than just mapping. We have 5 different mission areas that are listed here. So the Water Resources Mission Area, this houses all of our water science centers. So you guys have a water science center in New Jersey, and this is the mission area that Steve Collar is a part of. And the water science centers are responsible for our nationwide network of stream gauges, and they also conduct surface and groundwater studies. So the New Jersey Water Science Center is located in Lawrenceville. I found this historical photo on their website. And it looks like the hydrologists were handpicked from Boardwalk Empire back in the day. So one of our other mission areas that you're probably pretty familiar with is natural hazards. They have like our volcano notification system. They monitor hurricanes and earthquakes. Our ecosystems mission area. Our energy and minerals mission area is responsible for geologic studies. And then the ecosystems mission area, they do all of our biologic studies and monitoring. And Core Science Systems, which houses the National Geospatial Program, they're really focused on characterizing and understanding complex Earth and biological systems through their geospatial data programs. So specifically, the National Geospatial Program is responsible for the national map and all of its layers that are listed here on this slide, and helps to try to provide a foundation of geospatial digital data. So within the National Geospatial Program, you have the National Map Liaisons. I think there's less than 20 of us spread across the US. This map is constantly changing. We've had a lot of people retiring. We just hired on some new people. And what we're responsible for is providing outreach and coordination of geospatial activities. So we provide some science support to the Bureau programs or other organizations. We do outreach and tutorials, and we also assist with acquisition of geospatial data. Right now, we're mainly focused on hydrography and elevation data. And just to point out, these different mission areas here, like our agency gets kind of siloed in these mission areas and sometimes doesn't talk across them, but it's people that have jobs like me as a liaison. We try and keep those silos open and the conversations going so that we're not duplicating efforts across the different mission areas and we're all working together. So where I fit in as a liaison, I started out as the liaison for Pennsylvania, took on New York when Craig Neidig retired. And then when Roger Barlow retired, I took on his mid-Atlantic states, including New Jersey. We just hired someone that is now in charge of Maryland and Washington, D.C. So this is the final layout for now: Pennsylvania, New York, New Jersey, and Delaware. And I work out of the Pennsylvania Water Science Center. So that's the primary office in PA. It's right outside of the state capitol in New Cumberland. And then we also have a couple field offices in Pennsylvania. So I'm going to go over some updates today on our 3D national topography model. And just to start out, I'm pretty sure everyone here knows what a digital twin is. It's, a digital copy of a product, system, or process. And the goal is for it to be connected to its real life counterpart, which will allow the digital twin to dynamically update its status according to the status of its physical version. Some lofty goals here, but that's what they're doing now for cities. And what we want to do at the USGS is do something similar for the nation's topography. So we want to work on being relevant in the 21st century. Accurate 3D maps are heavily becoming just a requirement. It's not something extra, it's just the baseline these days. And we want our maps and our geodetic and elevation data to be accurate within centimeters. And we want to develop a national mapping framework that's continuous, from the tops of the mountains to the bottoms of the rivers. And this will provide coordination for integrated products. So we've got 4 development tracks that we're working on to achieve this 3D national topography model. The first one is completing nationwide elevation hydrography baseline data sets. So through our 3D elevation program, we want to provide the first ever national baseline of consistent high resolution elevation data that's both using the bare earth data and 3D point cloud data. So the way we're doing that is through acquisition of LiDAR data across the conterminous United States. Not going to go into what LiDAR data is. I think, most people here should know, using laser beams to reflect off of objects and using the resulting data to create topography models of the earth. And you could do bare earth, or you could pull trees or other objects out of the point cloud too. And then in Alaska, we're using IFSAR data, which folks might not be as familiar with. But this is a type of radar that has lower accuracy and is less detailed than LiDAR data. But we use this method in Alaska because it can penetrate cloud cover and operate from planes flying a lot higher and faster. So the 3D elevation program is focused on collecting high resolution LiDAR data. And what I mean by high resolution is quality level 2 or better. So quality level 2 translates to a vertical accuracy of 10 centimeters. And then we end up with a 1 meter DEM cell size and 2 points per square meter, or greater than or equal to 2 points per square meter. And so on this slide, you can see the difference between our 1 meter quality level 2 LiDAR data at the bottom, third arcsecond data that are available right now seamlessly for the country, for the conterminous US. And that comes to roughly 10 meters. And then we also have 1 arcsecond and 2 arcsecond products. And you can see, as the resolution, as we go from 10 meters to 30 to 60, it just gets fuzzier. And now we're even collecting at quality level 1, which is even more detailed than the 1 meter quality level 2 LiDAR that's shown at the bottom there. So I know this is hard to see, but it's just an overview of our LiDAR products that we end up with. Once we collect the LiDAR data, we end up with the LiDAR point cloud. We end up with an original product resolution digital elevation model. So that original product resolution DEM, that could be really in any projection. The tile sizes vary, and that's dependent on the specific project. And then the other product that we end up with is a 1 meter DEM. And that 1 meter DEM is standardized across the board. So we have our own tile scheme that we've developed for the entire country. So the point of that 1 meter DEM is to take all these different projects or DEMs from these different projects and standardize them into one product for the entire country. So this is the status of 3D elevation program, quality level 2 or better LiDAR data. So you can see New Jersey there, it's green. It's really easy to pull up a map like this and just show green across the entire country. But what you're really missing there is the fact that, this might be difficult to see, but to be able to show that green, there are a lot of different projects that actually went into that to come up with this, what we're calling a baseline data set. So for example, in New Jersey, you've got the 2014 Hurricane Sandy LiDAR that was collected, the 2015 Delaware Valley High Density acquisition, that was the DVRPC, the 2017 Northeast County LiDAR, 2018 FEMA acquisition, and then the 2018, they call it the USGS South. But I think those last three, the state was a partner for. And these are all QL2 or better LiDAR data, but these are specifically QL2. Yes, and then these two acquisitions that are circled, they were funded by New Jersey State and received independent QA/QC, and that's quality assurance, quality control. And what that means is that after the data are compiled, after the acquisition, all the data are sent to a completely different contractor and just checked for quality assurance and quality control. And I think this is one of the only states that does that. And it's really great that you guys do, because each time you've done this, you've found things that we missed in the data, because USGS does do its own reviews. But we always learn something from this independent QA/QC process. So it's a really great program you guys have. So now that we've completed nationwide elevation data set, we're also working on completing the nationwide hydrography baseline data set. And we've done that now, or we're still working on a little bit, through the National Hydrography data set, and specifically the National Hydrography data set plus high resolution. So what that consists of is it's our National Hydrography data set, which the NHD was derived from our old topographic maps and digitized, and a digital version was created of the hydrography across the nation. And they also worked on a watershed boundary data set to accompany that, deriving these things from topographic maps and digitizing. And the data, we had data steward, NHD stewards in each state who helped with the corrections of the NHD. And also we pulled in a 10 meter digital elevation model. That was like one of our first nationwide seamless elevation models to kind of help try and make the NHD more accurate. So once you go through all of that, you end up with the NHD plus high resolution. And that's what that looks like in New Jersey. And this data set is available online for download too. So now that we've got both the elevation hydrography baseline data sets complete, at USGS, we started working on pilot integration of hydrography and elevation. So what we wanted to do was to derive the hydrography. Hi, go ahead. Yes. Yeah. They call it the watershed boundary data set, and that has like the HUCs in it, or a HUC is a hydrologic unit code or we call them hydrologic units. And yeah, so they're essentially watersheds for anyone who doesn't know. Any other questions? Yeah.
The boundaries previously were off the mark. We all at local level. I guess I've got two questions. Is this going to be pushed down at any point? I mean, this can replace watershed boundaries that we've been working with for years.
So not.
Can you repeat the question so that people?
So the question is whether the hydrography that's being derived today from the elevation data, whether it's going to replace the watershed boundaries. So the answer to that is it's not going to replace them, but it is going to make them more accurate. So they will essentially be the same, but they'll have more, I guess, maybe undulations in them because they'll be matching the terrain that's apparent on that high resolution elevation data.
The state and their partners, I guess, are going through and creating these quality level 1 LiDAR products. Will that then be sent back through this processing and have even more refined? Here, this is the data that you use to create this is good enough.
I don't think I have the answer to that because, I feel like by the time we derive data from quality level 2 data, someone will be deriving it from quality level 1. And by the time that person's done, they'll be deriving it from quality level 0. Like this, as you could probably see in the last, 5 years, like stuff is changing so fast, and we'll probably just be trying to keep up with the next thing as we finish one thing. So I guess that's the best answer I could give for now.
I have a question from the chat here.
Okay.
If you could repeat it, please. Does the USGS still support the markup tool through which we can suggest items like culverts to improve the NHD?
So the question was, does USGS still support the markup tool? No, the markup tool was closed, and there will be something available, which I think I have that on a later slide, so I'll probably get to that a little later.
So let's hold our questions until.
Yeah, maybe, yeah, I'll pause, in a couple slides, and maybe people could reach out with more questions. So, like I said, what we're doing is we're starting to derive hydrography from this high quality, high resolution elevation data that we've acquired across the country. And we started with pilot integration of hydrography and elevation data. So we picked 5 Huck 10s. 2 were in Colorado, 1 was in Virginia, and then 2 were in Maryland and Delaware. And we did an internal project to derive hydrography from these 5 hydrologic units. And we just did that to build out our inspection procedures. We wanted to test out our specifications and try to understand how much it would cost to complete hydrography for these size areas. So this is an example of some of the hydrography that was derived for one of the hydrologic units in Colorado. And it's really great when you compare it to the NHD. It matches the landscape a lot better. you've got a lot more features in there. Pardon my computer, was struggling with this. But you kind of get the idea of what we're going for, and you can tell some of that looks a little blocky too. This was, one of our very first projects that we looked at. So once we wrapped up those pilot projects in 2019, we also began pilot projects in Alaska. Alaska had statewide IFSAR coverage relatively quickly. They have the Alaska Mapping Initiative, so they get a lot of funding through that. And we were able to really start on some pilot projects there. And then in 2020, we published our elevation-derived hydrography specifications and representation, extraction, attribution, and delineation rules. And what these are guidance documents for the contractors who work on these projects. So the way I like to describe it to the lay person is that we developed these specifications and these rules through research and all the projects that we've done, and we publish them. And now when we contract with contractors, or in some cases, we might have folks contributing data to this program eventually. What we do is we analyze the data according to these specifications and rules. So we don't necessarily care how you got the end product. You can derive something any way you want. The thing that we're checking for is we're taking that end product and running it through our specifications and rules to make sure that product matches the elevation data that it should have been derived from. Then both of these technical documents are also updated. I think they've been updated kind of on a yearly basis at this point. So, and everything is available online. It stays updated there. So the latest versions are 2023 revisions for both of these documents. So once these documents were published, we also started work on our first CONUS pilot project. This was in Southeast Texas, and it consisted of 10 10-digit hydrologic units. The location was outside of Houston on the coast. And I guess when they started out in Alaska, there was a lot of relief. And when they ended up in Southeast Texas, for some reason, they thought it would be a little easier to derive hydrography here. They found it was pretty difficult because it's just so flat. You've got a lot of canals down in this area, pumping water every which way. And then not to mention all the streams and water bodies, which with the tides will sometimes flow backwards. So they had a really hard time characterizing this area. It wasn't the cakewalk that they thought it would be. So this is a snapshot of what the final data look like. This is from our web service. We have a hydrography web service, which I'll talk a little more about, but the Southeast Texas data are available there for you to look at. So the second pilot project in CONUS was in South Central Pennsylvania. Pennsylvania NRCS was the funding partner on this, and it consisted of 3 8-digit hydrologic units. So the way these projects work are we have a kickoff meeting, and then the contractor will delineate a sample data set, which is usually a Huck 12 size data set. And once they delineate the sample data set, they submit it to the USGS for review. The USGS will review the sample data and provide feedback to the contractor. And then the contractor will use this feedback to make corrections and work on the remaining project area, 8-digit hydrologic unit at a time, so HUC 8. And then the remaining process basically involves a back and forth review correction interaction between the contractor and the USGS. So the contract will deliver a HUC 8, the USGS will inspect the data delivery and provide feedback in the form of a report, and then this process keeps going until the data meet USGS specifications. And in the case of this project, we had the kickoff meeting in July of 2021, and then the data were delivered to the project partner in August of 2023. So as with the Alaska to Southeast Texas projects, going from Southeast Texas to Pennsylvania, they said, oh, this will be great. We've got some relief again. Like, this should be way easier. It'll be just like what we're doing in Alaska. Well, it ends up, we've got this ridge and valley province, if you're familiar with geology, and these ridges and these valleys, the Ridge and Valley Physiographic Province, which part of it does extend into New Jersey there. So you've got sandstone and shale ridges, which are harder than the rock in the valleys, which is carbonate. And the rock in the valleys has a lot of surface depression, sinkholes, and caves. So here's another example of going from the Chesapeake Bay inland. You hit the coastal plain, then the early Mesozoic basin, which has a lot of crystalline rock, and then you get into this valley and ridge province, which has a lot of faults and folds, and you get the sandstone ridges and then the carbonate valleys. So this is what one of the areas looked like. This is what the sample data set looked like for that last project. And all the orange, the big orange dots are caves, the green dots are sinkholes, and then the small orange dots are surface depressions. So they had a lot of work to do in this area trying to characterize a stream that just disappears into the ground. And without doing a dye tracing study, you don't really know where that stream goes. So it's really, they had to find a way to attribute that or characterize that to kind of, stay out of the legal waters, but still kind of represent this on the land surface somehow. So this is a snapshot of what that final data set looks like. So the blue is the final data set, and we're uncovering it to reveal the NHD. So you can see the feature density has increased a lot. You've got a lot of the smaller tributaries represented there. And then it's probably hard to see, but the accuracy of the stream has also improved. So what we're hoping to achieve through this, what we're calling our 3D hydrography program, is to have more accurate alignment of our surface water features with the elevation data we're collecting. We want to provide uniform updates, have a simplified data model. They're really trimming down the attribution to make it more simple. We want to have national consistency of data quality and interoperability with NOAA's National Water Model, and then also with what they're doing in Canada. And better accounting of the hydrologic cycle through connections to groundwater, through the Fish and Wildlife Surface Wetlands Inventory, and then we also want to connect it to engineered hydrography. And then, bottom line, it will support and provide the geospatial underpinning for the Internet of Water. So on to the third development track here, designing and implementing the next generation of integrated data. So we have two call for actions that will hopefully, the first one is the call for action for the 3D hydrography program that should be published soon. And then they're also working on a call for action for the next generation of the 3D elevation program. So through the 3D hydrography program, moving on to this next step, we want to operationalize deriving hydrography from the elevation data, not just doing these pilot projects anymore. Eventually, we want to add in connections to groundwater, connect it to engineered hydrography and to wetlands. And then through the next generation of the 3D elevation program, we want to collect elevation data at new quality levels and frequencies. We also want to operationalize inland bathymetry. And then we also want to look at monitoring and change detection. So in transitioning from the NHD plus high resolution to the 3D hydrography program, we had to retire our legacy national hydrography data set. So like I mentioned, in response to that one person's question, we closed down the markup submissions, completed the markups, we closed external editing to the NHD, published a final version of the NHD, and that will be a static version. It will no longer be updated. Completing updates to the NHD plus high resolution and publishing that, which I think for a status update, they do have a lot of that published now. And they did close external editing to the watershed boundary data set. And I think they're still working on publishing a final version of that. So any questions so far? Okay. So also, we've launched a 3D hydrography program web service. What we did was we took all of the NHD plus high resolution data, and once we finalized it, we just dumped it into this web service. So as we complete these 3D hydrography program projects, we will be updating the data on the web service with the new data, with the elevation derived hydrography data. So this is a snapshot of just what it looks like in Trenton. That's what you're looking at there. That's the NHD high resolution plus. But if you open up the web service and you zoom into Washington, DC or Southeast Texas, you'll see updated hydrography there. So also we're operationalizing deriving hydrography from LiDAR. This is the status of our 3D HP programs so far across the country. So the dark blue is available or in progress. And then up in Connecticut, they've got a data contribution pending. So, and we want to have a structure in place for data to be able to be contributed to the program. So also in operationalizing the elevation derived hydrography, they started a new project in Pennsylvania funded once again by Pennsylvania NRCS. And this is also 3 8-digit hydrologic units. And we also want to enable better accounting of the hydrologic cycle by adding in engineered hydrologic systems. And this is something that Roger Barlow was really passionate about. He was really into looking at these hydrographic deserts that he called, which are apparent in the NHD plus high resolution data set. So this is just the NHD plus high resolution. All the blue, it's overlaid with a darker background. So anywhere where you see a lot of that dark coloring, that's just where there's no hydrography data. Do you have a question? Or
slide back when you said the state, one of the states up north.
Yeah, so I'm not privy to the oh, that's Massachusetts too, not Connecticut. I'm not sure on the details of that. We don't have a mechanism really in place right now for the contributed.
And if it's down, you could possibly New Jersey buy the fence with a better layer, and it might be accepted. That
Yeah, yes, yeah.
So it's not always big. We have LiDAR, you know, I don't know what the is done with the technology that makes me feel worse. They have a layer, I was just wondering, I'm gonna look into it, because I use all these layers in my dashboard, so that's why.
Okay,
Thank you.
cool, yeah. Yeah, feel free to get in contact with me too, yeah. So I've highlighted two areas on this slide, right outside of New York City and then the Philadelphia area that appear to be hydrographic deserts. And if you look at the Philadelphia area, that's really not a hydrographic desert. There are a lot of streams that run through that area, but they just run underground. They aren't represented in the NHD High Resolution Plus. So we do not have the system in place right now to be doing this across the country. But we were able to do it for a project in DC, and we're hoping to do it more where we work with a city and pull in their stormwater infrastructure data and are able to integrate it with our hydrography data that just it is better accounting for what is going on with the water, and it helps for better planning and for flood modeling too. So this is an example of what the hydrography in DC looked like before, and then after this project, with which Roger Barlow really kind of spearheaded with Washington, DC. They did an update and pulled in the city stormwater infrastructure to complete the hydrography in that area. Those data, you can look at the data on our web service. They've been brought into there. So also what we want to do is operationalize inland bathymetry. And so the LiDAR lasers, they do not penetrate water. So enable to really get a thorough national topographic model, we also need to model these rivers and streams. So for the larger ones, what they want to do is use topobathymetric. It's the green laser that will penetrate the water and collect the data. And then we could pull that data in and mesh it in with the topographic LiDAR data and have a complete profile of the topography. And then transitioning to the next generation of data through the 3D elevation program. So a lot of this involves collecting higher quality data where we can. So we really want to prioritize partnerships where there are no baseline data coverage, which there are still places that don't have baseline coverage. And then we also, where the baseline data do exist, we want to allow for new coverage and to collect quality level 1 or 2 data as preferred by the partner, and start updating data where the data are 5 years old or more. So this is just what the data will look like in New Jersey. So, you know, a lot of the state will be less than 5 years old, thanks to the 2 projects that are going on right now. And then the remaining part of the state the data will be 5 years old or more. So the way we're going about all this is through our data collaboration announcement. So the data collaboration announcement replaces our broad agency announcement, and we did this to be able to facilitate partnerships for elevation and hydrography data. And right now we're still doing those acquisitions separately, but the thought is that maybe one day we would have both hydrography and elevation integrated into one project. So we had a deadline for this, which, you know, New Jersey submitted a DCA proposal for, and so I'll get more into this too. So if you go on C-Sketch, this is what the federal priorities look like for that DCA proposal process. We like to prioritize proposals that focus on areas that have been identified as high priority. That's what those areas look like. And then, so New Jersey submitted a DCA proposal for Mercer, Burlington, Camden, Gloucester counties, and that's being awarded. So this project is, in the process of kind of being finalized. We're waiting on for the joint funding agreement, and we're super excited about this. So this will be quality of level 1 data. It'll be tide coordinated. The Delaware River is tidal up to Trenton. And then you've also got some streams in Burlington County that are tidal from the Atlantic Ocean side. It'll have machine-generated contours, machine-generated building footprints, and then thanks to DEP, independent QA/QC of 3-depth standard products and deliverables. So that's an exciting project coming up. The rest of our data collaboration announcement proposals, I think this is the primary one in this area that's been awarded, and we've awarded some other ones, but we won't be able to really move forward on some of the other things that are on hold. This project is moving forward, but we're still waiting for a budget. We're operating under a continuing resolution. I think tomorrow they're supposed to pass something. So as far as the data collaboration announcement for the 3D hydrography program, we haven't been able to make any announcements about this yet, just because this is not a budgeted program yet. So we need to wait and see what the federal budget looks like. So this map shows high priority areas for the 3D hydrography program. And this is the same map, just zoomed in to New Jersey. So a lot of federal priorities in New Jersey. There's interest from Fish and Wildlife Service, National Park Service, Forest Service, and EPA also has a lot of interest. EPA flagged the whole Delaware River Basin and the Chesapeake Bay watershed as high priority. So the way this program is working, it's quite different from the 3D elevation program. Instead of having data acquisition by county, we're doing it by hydrologic unit. So water doesn't respect political boundaries, so we figure we shouldn't be trying to acquire surface water features in the same way. So we're looking at hydrologic units, like I explained before. They're basically watersheds. So when we talk about like a 2-digit or 4-digit, 6-digit, 8-digit hydrologic unit, the smaller the number, the larger the watershed. So once you get down to like a 12-digit hydrologic unit, that's one of the smallest ones that we have digital data available for. So here's what New Jersey's 8-digit hydrologic units look like. So New Jersey includes portions of 12 different 8-digit hydrologic units, and 4 of these are located entirely within the state. And then we are also interested in collecting by 10-digit hydrologic unit, which New Jersey includes portions of 60 of those, and then 27 of those are entirely within the state. So the thing that other states are doing, which New Jersey might not be interested in, or sounds like you guys already have data that you might want to contribute. What other states are doing are some of them are forming multi-state funding coalitions, where if they want to cover a watershed that crosses into another state, they're partnering and divvying up the cost according to the area of the watershed that's within that state. In other cases, hopefully where there's federal interest, the federal entity, the NRCS or USGS, EPA, will be able to fund that portion that falls outside of the state, because we realize that states can't spend money outside their own state. In the case of New Jersey, we hope to have a system in place for contributed data. This program is so new. We don't have everything ironed out quite yet, obviously. So if you guys are if you've got that data derived from the quality level 1 LiDAR, we would hope that there would be a streamlined option in place where you could submit that data and we would run it through our inspection processes. And they're talking about hopefully putting some of these tools out to the public so that you can run your data through some of the tools yourself, just to see if the data meet our specifications.
Eliza, I'm not sure if the data was generated from quality 1 LiDAR or not, but I remember our former colleague Seth Hackman, who worked at the DEP. I think he's moved to finance or something like that. And I remember him boasting here in this forum, talking about how DEP got a 14-digit hug. First ones to do it. It was a big announcement for him at the time. I doubt that was generated in QA1. I don't know how it was generated, but is that the kind of data that could be run through this process that you're talking about?
I think so. Yeah.
Yeah, I didn't know if it had to be.
We're looking at QL2 or better. So yeah.
Okay.
Yeah.
So maybe it was. I'm not sure. I don't know. So.
Right.
But I do remember him saying 14-digit hug code. But at the time it didn't make sense to you.
Right. Yeah. So yeah, we're hoping that eventually there will be a system in place too, where it's like you contribute the data and we're able, maybe not necessarily even USGS looks at it, but a contractor could look at it and say, it's going to take this much level of effort to get this up to the 3-dep specification, and have some kind of an option where it's like you're not starting from scratch. So we're still working on developing that. So then I'm almost done here. So the final development track then is researching and developing that final 3D data model, where we're integrating the elevation data and the hydrography data and having that fully integrated 3D data model. Eventually, they want to integrate other data from the national map and then perform research activities like uncertainty and change detection. There's also been talk of, once we get nationwide quality level 1 LiDAR, where are we going to focus on updating that LiDAR data? Well, in the areas that have the most change going on. So there's talk of that too. And that's it from me. So feel free to ask questions and we could discuss this further too.
Anyone have any questions for Eliza, either online or in person?
Yeah, go ahead.
So you mentioned the built hydrography, adding culverts and things into the model. The state is collecting that information at scale as part of the general permit. Municipalities, highway entities, etc., are within a couple of years going to provide all that data to the DEP in GIS format. It won't be at first, but within 5 years, we might have something that can really be put into a model like this. So you planning on creating a system for accepting new data, I think it would be valuable to not just accept LiDAR data, but also to accept that kind of infrastructure data as well.
Right, and culverts are flagged in the new 3D hydrography program data model. So it's a feature within that data model. So, theoretically, if we're deriving a hydrography feature and there's a culvert there, it would be flagged or pulled out as a culvert attribute. If it's so, and that can go either way. Like if the stream is so small, it's not apparent in that elevation data, then the stream itself won't be included as a feature, and then we won't need that culvert in there if the stream doesn't exist. So that's kind of a difference with that too, where the culvert is used as a feature that signifies that this stream is going under the elevation and that it is monotonic. It's just not showing that if it's not burned into the elevation data, if that makes sense. Go ahead.
Do you have any rough time? Models? Or seems like that's, if you can get that down, it's going to really make things a lot easier for you guys, and that you don't have two competing funding.
Oh, you mean like integrating
The collection of it.
Okay, yeah. So, sorry, I didn't.
Like 5 years, 10 years.
I didn't repeat your question. I forgot. But the question I was just asked now was, do we have a timeline for integrating these hydrography and elevation projects? We don't right now. We just brought on the 3D hydrography program, so we're still waiting on a budget. So we're still trying to see how this is going to work out like this year, but there have definitely been discussions about it, and I think that's kind of where we're moving towards. Go ahead.
And what data are there for urban areas like footprints? Whereas cities?
Yeah, so that is, like I just said, that's definitely something that we want to start integrating. So the question was a potential timeline for integrating the urban hydrography into this kind of data model. So that's definitely something that's on our radar, but with the program just starting out, we're kind of tabling the hydrography or the urban portion for right now, and trying to iron out everything else, but it's coming. Well, thank you so much for having me, and if you think of something, feel free to reach out to me. My email address is up there, and thank you.
Thank you. Thank you very much, Eliza. That was great. Thank you very much. So I see some people came in. I just want to make sure there's no other constituency groups or task forces that have any updates, or if there's anyone else that has any updates before we adjourn. All right. Well, let's see. We have our next meeting is Thursday, June 6th, and that will be our lightning talk meeting. Hopefully we'll get lots of presentations. Patty, I encourage you to submit your dashboard that you were talking about. Maybe do a lightning talk here. We could certainly present a dashboard up here. So if you can't do it at the DEP, you could do it here, right? All right. Well, thank you all for coming, everybody. Have a great day.